The Aristona radio has a very bad distortion when the volume is rather high. And frankly, trying to discover the source of that problem is much harder than solving or rather finding the problem to a chassis which would not play at all, for example, or which would not receive any radio station, for example, because then it's fairly obvious what could be the problem. However, when the sound is simply distorted and there's no evident clue or clear clue as to why or what the reason or the cause could be for the distortion of the sound, then it really becomes problematic. Now, there might be several sources. First of all, the possible sources could be a bad vacuum tube, a bad volume potentiometer over there. It could even be the electrolytics I replaced, which are in the electrolytic can. Why not? It could be that for some reason or other they failed. It could be that any of the parts underneath the chassis failed, or more specifically, the parts that are related to the amplification part of the chassis. So, in other words, the reasons for the distortion of the sound can be many, and it's not obvious to isolate what would be the problem. Now, before I start all sorts of rather involved procedures trying to find out where the problem might be, I thought I would start by doing the simple things first, the obvious and the simple things first. So what I've been doing now for, say, the last half hour or so is clean all the tube sockets as well as I can from oxidation and dirt and all that, either by using a tiny little cleaning rod with a little bit of alcohol, or by using a contact cleaning spray. I bought one on the internet, and well, I don't know if it's good, but I think it's not too bad. And so I've been spraying liberally all the moving parts with the contact cleaner, and certainly the rotary switch contacts and the vacuum tube sockets, So I've been cleaning all that with the contact cleaner and or alcohol. Now, one of the possible sources of the distortion, although in my opinion it's unlikely, would be the tuning capacitor, which you see here. Now, whether or not the tuning capacitor is the source for the distortion of the sound, I decided that it might need a good cleaning anyway, and also to have a checkup, because turning it turned out to be not very smooth. So now it's fairly smooth. It's not extremely smooth, but it's smooth. Yeah, for a turn of the tuning axle, the tuning capacitor reacts instantly, yeah, which wasn't always the case before. So there is one little detail that might be interesting to all of you, and it is rather small, so I have to make close-up to show what I mean. Okay, so I hope the camera will be able to focus. Okay, so we're looking inside the tuning capacitor mechanism, and if you look carefully at where I'm pointing at, right here, right there at the tip of my pointer, you can see a tiny shiny part right there. And what that turns out to be is a single ball bearing. So, in other words, a tiny steel ball. And the shaft of the tuning capacitor, so if I rotate the tuning capacitor completely shut like this, so this shaft here of the tuning capacitor rests on that tiny ball bearing you see over there. Yeah, that tiny shiny little part over there. Now there is a hollow at the base of this shaft, and that little ball bearing is being pressed into the hollow of the shaft. Now the pressure on that ball bearing is set by this little screw you see over there, and the screw itself, once it exerts the right pressure, so this screw here, once it's set at the right pressure, it's locked into place with a tiny little nut like this one here. I don't know if the camera can focus on it, but yeah, there you go. So this tiny little nut here is eventually put back over that little screw over there. Now, how do I know how much pressure to put on that tiny little screw, this one here? Well, it's actually not too difficult to do. If you look at the shaft itself and you wiggle the whole mechanism with your hand, so let me zoom out. So if you wiggle back and forth like this, the end of the shaft, which rests on the ball bearing, should not move, or at least should move only very, very little. So if I release the screw a little bit more, so that it's really not too tight at all, like this. Let me see if you can see it. Yeah, so if I release the screw like about like here, and then I wiggle the shaft carefully, you don't need to do it brutally, you see the shaft can move back and forth quite a bit. In fact, you can see the tiny ball bearing moving along with the shaft. Yeah, so this is already too loose. So what you need to do is you actually need to tighten the little screw in such a way that you just start to feel a little bit of pressure. Yeah, so you can feel the screw moves a lot harder once you start putting pressure on the ball bearing. So you should just halt before that. And when you do, and then you wiggle the axle again, you should see that the end of the axle practically doesn't move any longer. And when you have that effect, then you know that you have put the right tension on the axle. And if I try to tune the radio, I can feel that rotation of the tuning capacitor is smooth. There's no tension. I can't feel any resistance really from the tuning capacitor. So in other words, it works quite well. So that's how you can set the tension on the tuning capacitor. Now there is one thing I did notice on the tuning capacitor, and that is that the outer plate, which is this one here, this plate here, is a little bit misshapen. So it's bent inwards, just a little bit too much, which means that when I turn the tuning capacitor, it probably makes contact with the fixed plates, which are mounted to the housing of the variable capacitor. And that will automatically create a short circuit. So what I'm going to do next is bend out this outer plate here, just a fraction, really a tiny fraction outward, and then I'm going to lock back the screw which regulates the tension on the axle with its nut. And once that is done, then I'll fire up the radio, see if that made any change at all, and if it hasn't, well, then we have to keep on looking for the cause of the distortion in the sound.
Op documenteren is, dan
Well,
iets een vraag stellen, meneer Esteer.
It seems like cleaning all the contacts once again and cleaning the contacts of the vacuum tubes and bending a slight little bit the tuning capacitor seems to have fixed the problem. Now the volume potentiometer unfortunately is not too good. As you can hear, there is a slight hum still in the amplification, and okay, it's not too bad. I think that kind of hum which you can hear is, well, unfortunately typical for these old radios, but like I said, the hum is not disturbing really. So I think maybe if I can find a replacement potentiometer for the volume knob, I might replace it, but it's doing fine, and I don't think I will do anything to it for now. So
ik was niet bang van wat allemaal te krijgen. Ik ben al veel sterk geweest in rammel te krijgen. Maar ik geloof dat je toch ook wel af en toe wat rammel hebt gegeven, hè? Nee, omdat ik koos altijd de zwaarste en de moeilijkste uit en de grootste.
It's playing at maximum volume right now.
Dus ik denk dat het daardoor ook meekwam met mij. Ik had die elegantie, laat ons zien.
By the way, it's a FM Belgian radio transmitter, and they are speaking Dutch. But as you can hear, there's no distortion in the sound, not even at maximum volume. So let's find another radio station and see if our luck holds up. Mind you, I'm not using an antenna, so that will probably influence the sound too. Whoa. Maybe I'm not so lucky after all. Of course, I forgot to mention another possible source of the distortion, and that could be the speaker itself. If the speaker somewhere in the past has been overdriven, it might be that the coil assembly of the speaker has been damaged, and that could cause distortion too. So, unfortunately, I think there's still some measure of distortion. So I will need to keep on looking for other possible causes, or maybe even try another speaker on the radio and see if that helps. I've been looking for the source of the distortion of the sound when the Aristona chassis is powered on. And in my search for more information about possible sources of distortion, I read a rather interesting article about the UABC80 tube, and part of it is here. Now, it turns out that the UABC80 is composed of 3 diodes, which you see here. So you see 1, 2, 3 diodes, and a triode or triode, which you see here. Now, the article clearly stated that it's quite easy to overdrive the UABC80, and as a consequence you would also overdrive the amplification tube or tubes. Now in this radio there's only one amplification tube, which is the UL41, this one. It's a pentode, and the anode of the UABC80 triode or triode is connected up to one of the grids of the amplification tube. Now it seems that you get the phenomenon which is called clipping when you overdrive the amplification tube. So if the signal is too strong coming from the triode all the way up to this grid, then instead of a nice sinusoidal wave, which goes like this, you get a clipped wave, which means that the top of the wave is flattened. And that, of course, provokes distortion. Now, what I'm going to do is I'm going to investigate these parts specifically. Why? Well, because this resistor dividing bridge, which you see here, and I hope the image is sharp for you guys. So this divider bridge here biases this grid connected to pin 6 of the UL41 to a certain negative potential, and it is driven by the positive voltage which comes from the anode of the UABC80's triode. Now, if the power which comes from this is too high, so the voltage in other words, or the bias voltage here is too low, then it's quite easy to overdrive the amplification and get a lot of distortion. So my best bet will be that either this or this resistor, or maybe both, are too high in value. So I didn't replace them, so it's quite probable that their values are too high, by which I mean that the biasing voltage on this grid is too low, meaning that it's probably quite easy to overdrive the amplification. So that's what I'm going to do next. I'm going to check on these resistors first, because I replaced all the capacitors you see here. So this one and that one and that one. So I'm pretty certain with those there is no problem. So I will concentrate on these two resistors or on these two resistors. If not, then I will move on to here, this part, just before or just around the triode of the UABC80. So because here is a potentiometer, the volume potentiometer, and these capacitors you see here have all been replaced. So the problem could be one of these resistors, or potentially the potentiometer might not be so good. But I think the potentiometer is fine, because all in all the amplification is really good. I mean, the radio plays really loud, so, and I can move it back and forth between playing quietly or very loud by rotating the potentiometer. So I think basically the potentiometer is okay. So to resume, the problem is probably or likely one of these resistors. So these two, or maybe one of these here. So which are 1, 2, 3 resistors. So let's start by checking these first, then these, and then these. Okay, so now I'm going to show you what sort of value I'm getting from my multimeter. Okay, so you see these resistors here, so this one and this one. If you look at the parts list, R33, which is this one connected to mass, R33 is a 560,000 ohms. See there, 560,000 ohms, or 560 kilo ohms. And R34, which is this one here. Let me show you. R34 is this one over here. Should be 270,000 ohms or 270 kilo ohms. Okay, so let's measure them. Now, if you look closely here, you see that the R33, which is a 500 or should be a 560 kilo ohms resistor, is this one, this brown reddish one here. Actually, the value which is marked on it is 530 kilo ohms, not 560, which is a bit strange. I don't understand why in the factory they would have put a resistor of 30k lower. But okay, maybe they didn't have 560 kilo ohms, so that's a bit weird. Okay, so then the other one is this tiny thin one here, this one here, and this one is supposed to be 270 kilo ohms. Okay, so, and these capacitors I changed. It represents a value of 14.7 nanofarad, which is close to the 15 nanofarad which is called for on the schematic. So actually, originally there was a 15,000 picofarad capacitor here, and I replaced it with a value of 14,700 picofarad, which is, I think, close enough. Okay, so let's measure the value of these two resistors. So this one, which is supposed to be 270k, and this one, which is supposed to be 560k, but of which I know already it's 530. Well, at least that's what's marked on it. Okay, so let's see. The capacitor is a common point between the two resistors, so I'm going to use that as a one attachment point. And now let's measure the one which is supposed to be 270k. So here we go. There you go. So I connected the 270k to the multimeter, and this is the reading I'm getting. So I'm on the 2 mega ohm scale, and as you can see, the value I'm reading is 0.43, let's say. In other words, it's 0.43 mega ohms or 430 kilo ohms. So that's definitely out of range. Yeah, so the schematic says that resistor that we're measuring right now, this one here, should be 270k. So that's definitely not good. Okay, so let's move on to the other one. And I don't know if you can see it, but there's a pin down there which I tried to connect to. There you go. Okay, and strangely enough, that resistor measures too low. It should be 530 kilo ohms, and it measures 270 kilo ohms or thereabout. So roughly half the value it should be. So that's definitely not good either. So what I'm going to do first is I'm going to unsolder the ends of those two resistors down there in the radio. So I'm going to unsolder each end of the resistor, and then I'm going to measure them again, and if their value is still too far off, then I'm going to replace them. Okay, I connected up new resistors to the points where the original ones were attached. I don't know if the camera is focusing, but I think it is. In any case, as you can see on this close-up, I reattached the replacement resistors to the spot where the original resistors were attached. And okay, hang on, I'm taking a pointer. So there is a tiny little mistake I made, and I'm going to explain what I mean by that. So you see these two resistors here, which are coupled together. Now, I didn't have a 560K resistor, so what I did was I used a 510K and a 50K or a 51K to make a 561 kilo ohm resistor, which is very close to the value it needs to be. Yeah, it should be 560, but it's 561. I don't think that one extra K will make a lot of difference. The other resistor you see here is exactly 270K. Okay, so that one is really textbook perfect. Okay, now what was that little error I was saying? Well, because I couldn't read the resistor value of the original resistor, which you see here, I thought I was reading 560K, but actually what's marked on it is not 560 but 330. But it's kind of hard to read. Actually, I can't. Ah, there it is. I don't know if you can see it, but it's marked 330K, yeah, and not 560. So my point is this: this one, which you see here, is marked. Oh, and this is even harder to see. Hang on. For this one, I really need a magnifying glass. Hang on. This one is marked. Ah, yeah, 560K. Okay, so if you could read it, but I doubt it because it's really tiny lettering, but let me see, maybe you can see it. Okay, now, so if you look at it carefully, I think you can just make out its value, which should read 560K. But well, it's really tiny. Let me see if I can make a close-up of it. Yeah, I think with a little bit of effort you might be able to read it. But trust me, this is the 560K. Okay, now remember what I first thought was the 270K, so that thin one here. I had was really the 560K. So I had to attach the replacement 560K to its location, which I did, as you can see. And the other one, which I thought was a 560K, was really a 330K, and that one was attached here. Okay. Okay. Now, okay, and I left the cross point or the attachment point between the capacitors and the resistors floating. So I didn't reattach them to the original pin of the tube because well, the pins are already quite a bit damaged, and well, it's just a tie point anyway. So maybe I might use this tie point, which is not doing anything, to attach those two, maybe, but it's really not essential per se. So we'll see. In any case, what I meant to say was that if you look at the schematic, R33 is supposed to be the 560K, yeah? So the one at which I'm pointing. Now, that is this one here, okay? So, what I'm going to do now is I'm going to turn around the chassis upside down like this, okay, and I'm going to connect up the speaker, but I'm not going to solder the speaker back to the chassis because well, I don't want to have to solder it on and off and on and off, because that would damage it. So I'm just going to use some crocodile leads to temporarily connect it up to the radio. Okay, so wait a minute. Hang on. So there you go. The speaker is connected up. Hang on, it's a bit hard. Come on. Yeah, there you go. Yeah. So the speaker is now hooked up to the radio. So what we're going to do now is we're going to turn on the radio, and we're going to listen and see whether the replacement, so replacing those resistors I showed you, will have done the trick of reducing the distortion we heard last time. I fixed a fuse holder to the bottom of the radio. And I'm going to give you a view of it. Whoa. Well, there you go. That's how I fixed the fuse. And as you can see, I made use of a soldering slug which wasn't used, and I bent a piece of gold-plated copper, thick wire. I think it's, if I'm not mistaken, It's 16 gauge, and I made a sort of a fuse holder to which I attached I made a sort of an attachment holder to which I attached a fuse holder, and as you can see, it works perfectly. I soldered one end of the fuse holder directly to the switch, and then I soldered the AC wire to the other lug of the fuse holder. And as you can hear, it works perfectly. Yes, the sound is finally distortion free.